Good morning and welcome to another episode of Data Talks Live. I'm Dr. Tom, and today we're going to talk data, all the topics that are relevant to data. So usually what I do in the morning is I just go through the news for the day related to data analytics, and look for something that's interesting, give you my take. So here's something. China spotlights major data center project using domestic chips. This is from Reuters by Che Pan and Brenda Go. China has built a massive data center powered by domestically developed artificial intelligence chips from Alibaba and other companies, state broadcaster CCTV said. CCTV, that's interesting. That's like a security camera. As Beijing seeks to wean itself off foreign technologies. The news comes as U.S. officials voiced national security concerns at trade talks with China and Madrid this week, aiming to block shipments of chips and other advanced technologies. Amid the tension, China has grown increasingly keen for domestic firms to switch to homegrown chips, warning them against the use of those made by the U.S. giant NVIDIA on security grounds. So everybody's pointing at each other saying, it's not secure. China's unicorn $300 million data center in Xining, the capital of the western province of, will possess computing capacity of 20,000 petaflops when complete, the provincial government says on its website. So far, the center has built 3,579 petaflops using nearly 23,000 domestically made AI chips. So I wonder about this. I mean, I wonder if this is really security concerns on either side, or if this is kind of a ruse and, we just want to bolster domestic production from a national security perspective, and so do they. And if we depend too much on outsourcing this stuff, then if there's some kind of a geopolitical conflict, the nation might not have enough internal capacity to meet their domestic demand, especially since I think a lot of these chips now are used in basically everything: military hardware, tanks, drones. Wow. Yeah. So it's probably important that those nations maintain some level of domestic production. I mean, obviously, I would prefer there would be no war, but that's not reality. On Monday, Beijing said a preliminary investigation of NVIDIA found it had violated anti-monopoly laws. Doesn't say which ones. Let's see what else is going on. ABB to invest $110 million in the U.S. to meet data center grid demand. This is the Wall Street Journal by Bill Gray. The investment will create 200 jobs. ABB said, whoa, yippee. $110 million, you get 200 jobs out of it. Oh, this is behind a paywall. ABB, I worked with them before when I was in electric generation. They built the big industrial transformers that we used. So I could see how they would want to get into this space. That's another thing that was interesting. A couple of months ago, Constellation Energy signed a deal with, I think it was Microsoft? I'm not sure. But the deal was essentially so that they would provide data center capacity or electric generating capacity for data centers through nuclear power plants. So, I'm pro nuclear power in a lot of ways. The sense that, you've got continuous baseline generating capacity at a relatively low cost with zero emissions. And I think you can design these plants safely. The biggest problem with nuclear power plants is they require a huge footprint. No one knows what to do. Well, a few problems. No one knows what to do with the quote unquote waste. My opinion is, what was the problem with the Yucca Mountain thing? I mean, just go bury it in the desert. There's landfills in every neighborhood in the United States, and no one seems to bat an eye about the mountains of garbage that we're sticking in the earth, but putting a little bit of depleted uranium in the middle of a mountain in the desert is somehow different and unacceptable. I don't get it. But yeah, it's also clean, doesn't emit carbon. So whether you want to acknowledge that carbon emission is a problem or not, if you take the conservative assumption that it is, logically reducing emissions is a good thing. If there's a 25% chance that the scientific community is right about climate change, then wouldn't you want to take the conservative approach and reduce emissions? I'm not saying at the expense of modern society, because if we got rid of all the fossil fuel burning things overnight, modern society wouldn't exist the way it does today. Even electric cars, I find that a little silly. You've got an electric car. Okay. Did you actually improve efficiency? Meaning, are you burning less carbon to move your car at the same amount of distance? Because you're still probably powering your car with a fossil fuel plant down the street. The difference is you just don't have to know about it. You have the convenience of feeling good because you have an electric car, which good for you. You want to feel good. We should do that. And maybe it is more efficient. I like hybrids. I think they actually are more efficient. If you think about it, so the power plant is in the car now, and you're storing the energy in batteries, and you're actually improving your miles per gallon. So your efficiency is actually going up. Now here's one, Milwaukee Journal Sentinel. Clean Wisconsin, I don't know what that is, says data center power usage could exceed all homes in the state combined. Wisconsin's approved data center projects may consume more energy. Oh, is it by Francesca Pica and Ricardo Torres. Consume more energy than all households in the state combined, according to an analysis from the environmental advocacy organization Clean Wisconsin. Okay, so probably biased. The analysis combined energy use estimates provided for Microsoft's data center at Mount Pleasant and the Vantage data center in Port Washington together. These two projects totaled 3.9 gigawatts of power, or enough to power 4.3 million Wisconsin homes. There are 2.82 million housing units in Wisconsin. Wow, that is not a lot. You think of an entire state, and there's 2.82 million housing units in the whole state. I think the population of Manhattan Island is pushing 10 million people now. So I wonder how it's laid out. I wonder if it's like, I mean, probably more dense in urban areas and less dense in rural, but still, it doesn't seem like a lot of people. Software-defined control, new architecture and practices in building automation. It's got a lot of authors. I'm going to link it down below. But it introduces a software-defined control paradigm for building automation, uses object-oriented modeling to enable logical abstraction for model reusability. The new system's control latency meets the requirements for building automation. That means in theory, they're going to say it's fast enough. So with building automation, you need systems that are fast acting, and demonstrate strong retrofit potential with minimum hardware changes. So the benefit of that is sometimes with building automation upgrades, you need to update a lot of your hardware equipment, and that comes with a big cost. So if you're able to make automation changes or retrofit automation without having to get new hardware, you reduce the cost. So let's see what they did here. The study proposes a novel software-defined control paradigm for building automation systems. So building automation systems, think of HVAC systems, fire suppression systems. Those are good, some solid examples. They use a lot of them use what's called a programmable logic controller. So essentially you program the logic into this computer and it says, when this valve opens, this valve shuts. When this turns on, this is the thing that turns on next. Compressors, another good example of building automation system where you need compressed air to run your operation. PLC-based architectures are vendor locked in. So this is really common. A lot of these automation systems in general are proprietary, and the vendor will invent some specific protocol or create some closed loop system or, and basically the intent is to make it so they're the only people that can work on this stuff. So that's a problem for not just cost when you want to make a change, but it's also a problem for maintenance teams. When a maintenance team wants to work on something and they can't access a proprietary based system without the vendor, and you're entirely reliant on the vendor to make fixes or improvements through software updates or what have you, that basically locks the in-house maintenance team out of being able to work on this stuff. And if you're in a production environment, you might need stuff back up and running right away. And so waiting 8 hours for the vendor to show up at your facility to work on your equipment isn't always acceptable to your management team. Been there. The purpose of this research is to explore how software-defined principles can be applied to decouple logic control from hardware, thereby creating more adaptable, intelligent framework for building control. Methodologically, the system employs a 3-tier hardware architecture combined with a containerized browser-server software design. At its core, an object-oriented model framework generalizes building devices into standard logical signals, while low-code orchestration engine based on BPMN 2.0 allows intuitive drag-and-drop configuration of control processes. This approach reduces reliance on specialized PLC programming, expertise, and enables broader participation of operation and maintenance staff in control operation. Experimental evaluations demonstrated that the SDC system achieves a median control latency of around 200 microseconds and delivers closed-loop performance comparable to PLC systems. So what they're saying is they can do this with software and not a closed-loop PLC, meeting the real-time requirements of building control and thereby confirming its technical viability for real-time building automation. A real-world retrofit case study in semiconductor facility further validated the framework, achieving 9.6 daily energy savings through autonomous optimization of HVAC operations. There you go. The finding highlighted that SDC not only replicates baseline PLC performance, but also extends flexibility. So basically, they're saying they can do this with a drag-and-drop software model that they created rather than using a hardwired PLC. I guess they're saying they're going to do it over a network. I wonder about cybersecurity concerns of that. I have to look more into the architecture to see whether they've accounted for cybersecurity concerns, if they're planning to do this on the open web or not. This paradigm offers significant value for both new construction and retrofit projects, advancing building automation towards higher level of sustainability and intelligence. So I wonder how they would do that in a retrofit, because you're not going to reprogram a proprietary PLC. You may have to, and if the PLC system is designed to work with the hardware, yeah, it's not totally straightforward, but it seems like they did it. So that's interesting. Yeah, I think that's always been the problem with these ideas. We had something like this, similar to this where I worked. It was proprietary, but it was not a traditional PLC. It was through network devices that we were controlling the automation system, and latency was a problem. The other thing is, server maintenance issues abound, right? Server shutdown was a new failure mode that we had to deal with that in a PLC closed loop system you wouldn't have had to deal with. So probably not a perfect approach, but definitely something there. Interesting that they're exploring it. Probably a good thing if you can get it to work right. I don't know about mission critical systems, life-saving systems, backup diesel generators in a hospital that are meant to kick on when power goes out, that kind of thing. You really need high reliability, and that's just not discussed. And another thing is these systems are targets for cyber attacks. And, you know, changing the architecture here could make you more vulnerable or less vulnerable to cyber attacks. So that's something you should consider as well. Okay. Well, that's, I think, all we have for today. This has been another episode of Data Talks Live with Dr. Tom. I'm Dr. Tom. And until next time.